Okay, first up we are asked to find or to apply some of our knowledge of trigonometry, and you define unknown side lengths or angles. So what we do, we just apply our what we know about trigonometry. So to set up in right angle triangles, we've got an angle, we've got a side length, we're calculating an unknown side length. Over here, a little bit more complicated, a little bit more work, and we'll see the steps we need to take to be able to calculate this, because here we've only got one side length, so we're going to have to work another one out. Either way, you've got to remember these things: SO, CAR, and TOA. SO stands for sine of the angle equals opposite length over the hypotenuse length. Cos of the angle is a ratio of the adjacent side length over the hypotenuse, and tan of an angle is a ratio of the opposite side length over the adjacent. These we're going to use here in this context. You'll also have to make sure you know how to use them when we're looking at a thing called a unit circle. Okay, so let's have a look at our first problem here. So we've got an angle, that's our theta, and as well as that we've got an opposite side length because it's furthest away. We've also got our hypotenuse because it is opposite the right angle. Now because we've got opposite and hypotenuse, we're going to use SO, which tells us sine of theta equals opposite over hypotenuse. In this case, we're dealing with sine of 40, because 40 is our angle, equals our opposite side length, 10 over the hypotenuse, or in this case we'll call it lowercase h, that's what we're dealing with. And from there we imply that h equals 10 over sine of 40. And then through our calculation we'll find that is 15.56. Okay, moving along over here, we're trying to work out the angle. Now, we've got a side length, we've got an angle here, and we've also got a side length, we've got the opposite side length. So what we want to do, now here for this triangle, we've got these two side lengths here, so what we want to try and find, this side length there, and I'm going to call it x. X serves as the hypotenuse and also the adjacent side. So first thing we're going to do, we're going to work out how long it is, treating it as the hypotenuse. So for x equals the square root of a squared plus b squared. We've got our 6, 8, and it's a right angle triangle, so we find the hypotenuse. So we've got 6 squared plus 8 squared, take the square root of that, and we end up with 10. So that's what we've got there. So that's our side length x. Now, we're going to try and work out the angle. So that we've got an adjacent side, and we've also got an opposite side there. So we say that tan, so if we've got opposite and adjacent, we've got TOA. So that is what we're working with. So saying TOA, which tells us that tan theta equals opposite over adjacent. So now we know that tan and a, because that's the angle we're dealing with, equals our opposite side length of 12 over our adjacent side length of 10. So from there we imply that a equals the inverse tan of 12 over 10. Plugging this straight into CAS, we'll find that our angle ends up being 50.19 degrees. So we've got our triangles, recognition of SO, CAR, TOA, working out which one to use and how to apply it. This is pretty much the steps I'd like to see you working through. So drawing your diagram, determining a ratio, and then showing all necessary working out.